When assessing the treatment of a patient with brain metastases, it is very important to understand if the treatment is effective or not. Therefore, we want to assess the efficacy of the treatment. A radiologist would then compare two MRI brain scans and see if the lesions grew, if they disappeared, or if there are new lesions. I will now put you in the shoes of such a radiologist. You're happy because you're lucky actually, because the scans have already been pre-segmented. I want you to tell me how much did each lesion grow, and if we have new ones, or if we were able to get rid of some of the lesions. And as I told you before, as you can see in the video now, the scan has already been pre-segmented, which is usually done by a radiologist, or in the near future by an AI system. I was messing with you a little bit here because it's rather difficult to do that in such a short period. Let me tell you now, our algorithm can tell you the answer to the questions I asked before in 10 seconds. Let me show you how we do it. So in order to achieve the high sensitivity that you have read in the title before, we didn't go for an overlap-based approach. We went to use other characteristics of these lesions in order to track them over time. So we took the centroids of each lesion, and then we calculated vectors that connect these centroids. We then placed a mathematical sphere around the whole brain volume. These vectors would then intersect both the centroids of the lesions and then intersect with this sphere. Therefore, we get very characteristic distances. We will then use these distances to feed into matrices, which we then can compare. And the one matrix with the smallest distance in between of them corresponds to the matching lesion. We will then get an output which the radiologist can visually inspect if the algorithm was correct or not, or if it even makes sense what he said. This algorithm has been tested on real patient data, where we achieved a 93% accuracy. We then also went further and created artificial data, which the algorithm was tested on again, where we achieved 90% accuracy. With this thesis, we were able to prove that these characteristic distances can be used to track them over time, and this algorithm shows potential to be used in a clinical setting.